We're going to start off by understanding just the general anatomy of the ear. So we have the outer part of the ear here, which is made up of a pinna and an external auditory canal. Then we have the middle ear, which is made up of the tympanic membrane, and then the three bones, the malleus, incus, and stapes. And then the inner ear here is made up of the semicircular canals and the cochlea. Here's a bigger representation of the three bones in the middle ear. We have the malleus, and this is the area that would articulate with the tympanic membrane. In the incus and the stapes, here is where we articulate with the oval window. So if you're thinking of the shape of a snail shell, it's about the similar shape of a cochlea. And then if you wind it out and have one long piece, and then take a cross section, this is what we'd be looking at. This is a cross section of the cochlea, and the cochlea is divided into three separate chambers. There's the vestibular canal, the cochlear duct, and the tympanic canal. The fluid filling both the vestibular and the tympanic canal is a perilymph fluid, and the fluid in the cochlear duct is an endolymph fluid. We also have this smaller organ right here, which is the organ of Corti, which contains the small hairs and the sensory nerves. So the sound waves are first received by the pinna, and then they're channeled into the external auditory canal. The sound waves cause a vibration in the tympanic membrane, which then vibrates and causes the three bones to vibrate. The vibration is then picked up in the oval window and causes a displacement in the fluids in the cochlea. As the vibration enters the fluid in the cochlea, the small hairs that are in the organ of Corti are displaced. When this happens, potassium ions rush into the hairs, causing a depolarization. The depolarization of the hair cells causes calcium channels to open at the basal end of the cells. So this is about right here, and calcium ions flow in. The vesicular transmitter is then released through exocytosis, which stimulates the nerve. The impulse is then carried via nerves, and it is carried to the central auditory system of the brain, which is where the vibrations are interpreted into a sound that we understand.